All right, welcome back, everybody. Good to see you all again. So what we're going to be looking at here, now that we've had several logical sort of laws and other things under our belt, now we want to take a look at sort of putting these things together. So one of the things about logic, when you think about logic, right, one things that, things that seem to come to mind are just order, this idea of putting things together, putting information, piecing information together and drawing conclusions. And that's going to be something that, not only is it done in the logic that we use in everyday life, it's also going to be used here in our Boolean logic as well. So what we're going to be looking at is this idea of an argument. Essentially, if you think about an argument, especially those of you who've done debate or you've done written position papers in your humanities classes, right? The idea behind that is to put together evidence, put together pieces of information that, when you put them all together, allow you to come up with another piece of information that should be true at the end. And as always, with any claim, you want to make sure that you can back up that claim sufficiently with whatever other data you need. The same is going to be true here in a mathematical sense. So we're just going to be looking at this idea of what's known as logical arguments here. So consider the following here. Let's say that this logical argument here, let's say that these statements are going to be true. We'll start off with this statement here that says, if it is my birthday, then my friends are going to throw me a party. And it's also said that it is my birthday. So what seems to be the case here is that, well, wait a minute. If that's the case, if it's my birthday and then my friends will throw me a party, and it is indeed my birthday today, then it seems to be, the conclusion that seems to be drawn is, the thing that comes out is the fact that my friends will throw me a party, right? Now, why does that work? Well, we have a conditional here, and we have the first part of that conditional. We'll look more into the why behind of it here. But this is an example of a logical argument here. So in this case here, one of the things about these sorts of logical arguments is that instead of writing it out in words, we can write it out in symbols. So we can think of our logical argument as something like this here. So you'll see, oops, sorry about that, ladies and gents. You'll see that for our logical argument here, we have something that kind of looks like this. So we can actually write everything out like so. So you'll note that there are a couple things about this logical argument here. Up here, these two things on top, this represents sort of the data. This is our, the evidence that we have here. These are what are known as premises. These acts as the evidence for the argument. Now, if you're trying to make a coherent argument here, it doesn't make much sense if you start off with pieces of information that's not true, right? You want to make sure that you have true statements here. So these are always assumed to be true. Now we assume these to be true here. Presumably, when you're creating an argument, you're going to start off with true statements. You can do your research first and find true statements to start your argument with. So you know that you have that. So here's your things here. And at the end, what you have on the bottom here is, at the end, we have why. This represents our conclusion. This is what happens as a result of our premises here. We create our premises, we have our conclusion here. So you can see that the bar acts as a separator between the premises and your conclusion here. Now, some of you may know, wait, there's something else we missed here. This symbol over here. This symbol over here represents the word therefore. So in this case, we're saying if X implies Y and X, therefore Y is true. So in essence, what's going on here, and we can see that our arguments are going to take on this form here. This is a very simple argument, and as the arguments get more complex, we'll have more premises, and we can eventually get to another conclusion here. But this is just sort of the general idea behind how an argument is going to work. Okay? So notice what happened here in this situation. What seemed to happen was that we had this thing here. We have X implies Y and X, then we get Y at the end here. So the first thing to note about this argument is that if we go back to the beginning here, we went back to this, we noted that there was a matching between a conditional statement and the initial portion of that conditional statement. These happen to match up, right? So we seem to have this sort of thing here that there was identical. So in this case here, we seem to have this sort of idea of a matching here, right? So this here, if I were to write it over here, let me write it on this side here. We have X implies Y and X. We have a matching here. And that matching here allows us to sort of, it feels like what we can do is we can kind of take that thing and break it off here. We can kind of pull it away and be left with what's left over, and that's our Y here. It's almost as if we're taking the conditional and we're, pulling off the first part of it. We're detaching it here, okay? So in this case here, what we have is something that is known as the law of detachment. So what we have here, this is known as the law of detachment. And you'll see that I have all these notes here about what's going on. Basically, it's telling us this here. So it's just sort of, this is our argument written out in symbols. So in other words, we can say that if a conditional is true and its hypothesis is true, then the conclusion has to be true as well. Okay? So the idea behind this is, well, you know, it does make sense that it should work here. By the way, for those of you who are not sure about this, this here, modus ponens, is the original Latin name for the law of detachment. You can do some, you know, this is if you want, if you're really studying Latin or things like that here. The full Latin name of this law is actually modus ponendo ponens, which translates to English as that which affirms by affirming. Yeah, Latin's kind of weird. Anyway, so one thing we can consider here, we're going to show that this is, you know, our intuition tells us this is true. But let's look at things in terms of, truth values, right? Because if we take a look at this, for instance, let's look at this here. These are premises, right? These are premises here. We say that premises are always going to be true. So P is going to be a true statement here, right? So P is a true statement because this thing is true. And this thing is true as well. So that means this P here has a value of true, right? So that's why I'm putting a little T next to it. Now, what is Q? If we know that this conditional is true, Q has only two values. It can be true or it can be false. If Q are false, then you have true implies false, and and according to what we know about conditionals, true implies false leads us to a false statement, and that contradicts the fact that this is a premise and therefore it's true. So therefore, we have no choice but to conclude that Q is true as well. Q is true as well, and therefore Q is a true statement down here. My apologies. So therefore, what we have here is that when we deal with this, so we can look at this in sort of terms of we can see this in terms of truth values, and we can see that this is indeed a true statement here. Now, you'll sometimes note that we can also write this law here, the law of detachment, we can also write it out like this here, as P implies Q and P implies Q. So notice how in this situation our premises here, this is premise 1, premise the first, this is premise the second. Notice that premise here, the two premises are joined by an and because we're given them both as true, and then this is our conclusion here at the end. Now, this statement seems a little bit more, similar to the ones that you've seen in truth tables. And in fact, if we were to do the truth table for this, I'm going to leave this as a bit of an exercise for you. So I'd like you to go ahead and consider, creating a truth table for this statement here. And you should note something very important here. Now, when you do the truth table, well, I'm not going to spoil it for you. I'm going to let you think about that. I guess we'll talk about it later on.